today we're going to talk about exponential growth and decay word problems. It's the moment you've been waiting for, seeing where this stuff actually occurs in real life. So we'll have some problems that have the word increase or get larger over time. That's exponential growth. And we'll have some questions that deal with loss or decay, which is exponential decay. The first formula over here we're using is our exponential growth formula. And the formula is actually the same for decay. And the only difference is that it has a minus sign between the 1 and the R. So the A stands for the starting amount. The R stands for the rate of growth, which is usually indicated with a percentage sign. And the T is the time that's elapsed. So we have 4 example problems, and this should pretty much encompass all the different types of problems. So the first one says movie tickets now average $9.75 a ticket. So we're going to underline that. That's important. But are increasing at a rate of 15% per year. How much will they cost 5 years from now? So the time that we're looking at is 5 years. That'll be T. The starting amount is $9.75, so that'll be A. And the rate is an increase of 15% per year. So we'll make that the rate. And when we go to plug in, we'll be solving for Y, which is our amount after 5 years. Now, what's really, really important here is for rate, not to plug in 15, but to plug in 15% as a decimal. So since it's 15%, which is 15 over 100, you want to move the decimal 2 places to the left. And then the T is a little 5. So if you struggle with making percentages into decimals, just a little reminder, you put a dot at the end and you move it 2 to the left. So when we go to do this, you can actually type this whole thing in your calculator. So if you're using a scientific calculator, you could type this and type parentheses 1 plus 0.15 and then hit this little caret key to the 5th power. If you don't have access to that kind of calculator, you can also follow PEMDAS by doing parentheses first, which gets us 1.15. When we add that together, 1.15 to the 5th power, we'll probably have to do that in our calculator, and we'll just do our best to round. So I got 2.01. If you do this whole thing in your calculator, you're going to get probably a slightly different answer, and it's probably even more accurate. So 2.01, I'm just going to round it to the nearest hundredth, and then I'm going to multiply 2.01 with 9.75. So I know that the price of a movie ticket is going to be about 19.5975. I'm just going to round that to $19.60. So when you use PEMDAS, you would do parentheses first, exponents second, then you would do multiplication. So they're really not too bad. And if you do want to go with the calculator route, if you put this whole thing in your calculator, it will do it for you. I don't have a scientific calculator in front of me right now, so I'm going to be showing using PEMDAS. This one here is talking about loss. So we automatically know it's decay. So the big difference here is the rate is decreasing over time. So it's going to be a subtraction. A powerful computer is purchased for $2,000. That's the starting amount, but on average loses 20%. So the rate is 20% and the amount is 2,000. And we want to know how much it'll be worth 4 years from now. So we'll do y equals 2,000. 1 minus 20% is a decimal. Moving that decimal 2 to the right is 0.20 to the 4th power. So you can put that whole thing in your calculator, making sure to use parentheses and your little caret key. Or you could do subtraction first in the parentheses, because P always goes first in PEMDAS, and then exponents next, which is about 0.4096. You could round that more if you want. As long as you show me how you round and you show your work, even if you get a slightly different answer, I'm still going to count it. So that comes out $800.19, or $819.20. Now that is, wow, that's a huge difference compared to that. So you can see how much decay really impacts our everyday items. Let's try this one. If a gallon of milk costs $3 now, so that's the starting amount, and the price is increasing 10% per year, so that's our R. Increasing is important, that means it's growth. How much will it cost 5 years from now? So we have y equals A, 1 minus r to the t is our formula. 1 plus t, sorry, because it's increasing. So we have the $3 as the starting amount. The rate is 0.10 because 2 places to the left. Our t is 5. So we can use PEMDAS here. Do parentheses first, and then raise 1.1 to the 5th power, which is 3 times 1.61. So once again, you can use your calculator if that's better for you, just using that caret key. You could even use your caret key down here if you're doing your PEMDAS. 1.61 times 3. Could probably do that one in my head, but I'm trying to use a calculator for it. And that turns out $4.83 will be the price of the gallon of milk after 5 years. Let's look at this last one together. So we've had a couple increasing. This one's also increasing. Just kind of noticing those words first is really good. This one's a little bit different. So dinner at your grandfather's favorite restaurant now costs $25.25. And has been increasing for 4% per year. So I know that's the rate. How much did it cost 35 years ago? All right. So for this one, it's a little bit on the tricky side because it's asking you to go back in time. So you can go ahead and make this the time. And we have increased rate. So we're going to write out y equals a 1 plus r to the t. And we are asking what it cost 35 years ago. So this is where it's a little trickier. So 35 is the time, but what we don't know is what it was 35 years ago. So we don't know A. We do know the rate is 4%. It was increasing 4%. So that is 0.04. We got to add a 0 in there. It's Halloween, so my dogs are going a little bit on the crazy side. Lincoln, come here. So thanks for your patience during this video. It's okay. It's okay, baby. So when we're doing this problem here, we got our y equals typically, and we usually plug in this number, but this is slightly different because we don't know A. We don't know what it was. But we know it now costs $25.25. So that's your y. and we don't know A, we can still combine the 1.04. This one you can't necessarily do using PEMDAS. You're actually trying to solve for A, so it's kind of the opposite of PEMDAS. So if you remembered from a previous lesson we did in here, which was SADMERP, which is subtraction, addition, division, multiplication, exponent, radical, and parentheses. We're actually going to go ahead and work with any sort of multiplication, addition, division stuff first. So we can go ahead and divide by A. And then we can raise 1.04 to the 35th power. So if we do that, we almost have to use our calculator, but you can hit your little arrow key. So 1.04 to the 35th. And I'm going to round it to the best of my ability. So it's 3.946. And technically, I just realized you wouldn't have to divide by the A, but since I've already done that, that's fine. But to backtrack here for this one, it might be a little bit easier for you guys if we actually leave the A. So my apologies. Let's just leave the A on there, but let's reverse the order. So that way it looks a little more familiar to us. So can't really do this one in the calculator. It's a little different. But at the end here, we can divide by our 3.946. If I can fit that on here. And we'll have $6 and it says 0.398. So I'm going to round it to $6.40. And you can see that a meal that once cost $6.40 now costs $25.25. You could probably set up a problem where you use the opposite formula if you were going back in time and make t negative and get the same answer. I'm now really curious to see if that works out. So we can try that out if we'd like to. That would be using this opposite formula, but plugging in. So we would use the subtraction, and I am interested to see if this works out. So I want to try it out. So if the meal, let's say the starting amount was $25.25, and we are going back in time 35 years, and we made this a negative 35 exponent, I'm interested to see if that would work out. But just knowing that it would be decay in that case, because we're going back in time and it would have been cheaper. So I want to see if this gets me the same thing. This you could do in your calculator to check. I'm going to go ahead and do PEMDAS. So if I do 1 minus 0.04, I get, it keeps coming up a little bit weird, 0.96. I know it should be bigger than that. I want to use my parentheses when I raise that to the exponent of negative 35. We're going to have to see if that works out. So we'll go 0.96. Let's go ahead and show how to do that just to make sure you got it. 0.96. And we want to raise it to the negative 35. Let's see if we're able to do this in here. So we get 4.17 about. And we're going to multiply our 25 times our 4.17. I'm really interested to see if this works out. I've actually never thought to do it this way. So for that, I actually got 105. So when I tried it this way, I just wanted to see if it would work out, and it actually doesn't work out. So essentially, If you wanted to try it this way, just knowing that that's not going to work out, and I wanted to kind of see if it did or not, because I honestly did not know. But it's good to know that when we have a problem like this and we have the ending amount, but we want to go back in time, we can still use 35 as our time, and we can still use the plus for increasing, but we have to solve it a little bit differently in order to get our starting amount. So a little rehash on what we did is we added the 1 and the 1.04, getting us the 1 and the 0.04, which got us 1.04. We raised it to the 35 because that's how many years ago it was. And then we are solving for the starting amount of that dinner. So we leave the A. 1.04 to the 35 is 3.946. And the ending amount is 25.25. So we divide both sides by 3.946. And we get that the meal was $6.40. And if you wanted to check it, you could plug in the 640 for A and do PEMDAS here, and you would get 25.25. So that's just a little option on how you could check it. So sorry for the interruption with my dog on this video. I hope this has helped. And if you have any questions, please let me know. The two formulas will also be on your formula sheet, but here they are up here.